So I told there are two types of ellipses. So depending on which side the length is more. So when you take an ellipse like this, what was the name of the ellipse that I told you?
Horizontal ellipse.
It's called a horizontal ellipse, where the endpoints of the horizontal ellipse is going to be a comma 0 and minus a comma 0 on the x-axis. Here it will be 0 comma b and 0 comma minus b. X dash y dash. So the center is called as the origin, right? So I hope this point you guys remember. So this is a horizontal ellipse. Let me just give you some introduction. Then I will take you through the derivation. Okay. The next is an ellipse which is kept like this. So what is the name of this ellipse? Obviously, it will be the vertical ellipse, right? So what are the endpoints? The endpoints are still going to be a comma 0 and minus a comma 0. Here it will be 0 comma b and 0 comma minus b. This is y, this is y dash, this x dash. Okay. And center point is still origin. Now comes the question of, so here, see, a is greater than b. Here I can say a is less than b. So here what is a called as? 2a is called as the major axis and a is called as the semi-major axis. Similarly, what is 2b called, guys? Right, and b is called as the semi-minor axis. Right. In a similar way, here also you have the same thing. So 2b will be called as the major axis, and b will be called as the semi-major, and 2a is called as the minor axis. A will be called as the semi-minor axis. All these things are okay. Okay. So let's see, based on there's all whatever we discussed till now is based on the diagram. Now we will discuss the concept based on its definition. Let's see what is the definition of an ellipse. So write down, an ellipse is a set of all points in a plane. So write down this definition. An ellipse is a set of all points in a plane such that the sum of the distances from that point to two fixed points in a plane is always a constant. Okay. So I'm repeating it again. Ellipse is the set of all points in the plane such that the sum of the distances from the moving points to two fixed points is always a constant, and those two fixed points on the plane are what are called as the foci. F-O-C-I-I. You can either pronounce it as foci or foci. So generally, whichever term ends with US, no? For example, focus is singular. If you want to say it in plural, you replace that US with I. So foci or foci. Is that clear? I hope it is clear till this point, right? Now see, I will just show you. So if at all, I give you two fixed points with the name of focus. S1 and S2. Let's say there is a point which is moving. So if you measure the distance from S1 to P and S2 to P, let's say this distance is D1 and this distance is D2. So according to definition, what should happen is S1P plus S2P should always be a constant. That is D1 plus D2 is always a constant. That is the meaning. Okay. Suppose this point P is somewhere over here. If I call this as P1, let's say it is moving in anti-clockwise direction. Now what you will have is, you will have D3 and D4. Similarly, D3 plus D4 will also be a constant. Similarly, when it comes to some point here, then this distance will also be constant. So if you join all those points, the shape that you're going to get will be looking in the form of an oval, and that oval shaped structure is what is called as an ellipse. Okay. Now our work is to derive the expression for ellipse in terms of its major axis and minor axis. Shall we start?
So I have a doubt, sir.
Yeah, tell me.
Isn't it only D1 plus D3 plus D2 plus D4 is a constant?
No, 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 no. From the point P2, from point P2, how many lines are going? One line. I'll use red color. See, this is S1 P2.
So,
This
sir,
is
only
S2.
for that point, the sum of two lines for that point.
Yes, yes, yes. This is a moving point. This is not a fixed point. See, this point is moving. You're able to understand. S1 and S2 are fixed. S1 and S2, they are not moving. They are fixed points. Whereas if I take a point P, which is moving in such a way that it follows this condition, what condition should it follow? That from the point P, if you join to those fixed points, you will get two distances. No. If
Yes,
you
sir.
add those two distances, and every time the sum of those two distances comes out as a constant, then that moving point is definitely moving in the shape of an ellipse.
Okay, sir. Understood, sir.
Okay. See, in some books, generally in NCERT, it is not given. This moving point is also called as locus point. I didn't introduce this because you might get confused between locus and focus. Locus is moving point. Focus is fixed point. So don't get confused. The one that starts with L is moving point. The one which is fixed is called as the focus. Okay. Now I'm going to introduce certain terms. So concentrate. See, it is slightly a tougher version. I will not say it is so tough. Concentrate, you can understand. See, for a parabola, when we did, how did we define parabola as? So parabola is a shape that you will obtain when the points are moving in such a way that the distance of the point, that the distance of any point to a fixed point is always equal to the distance between the moving point and a fixed line. You guys remember this? So if I take this SP, this is PM. So if SP is equal to PM, then we call it as parabola. Accepted? Now see, SP is the distance between moving point and fixed point, divided by PM is the distance from the moving point to the fixed line. So this SP by PM is generally given a term called as eccentricity. Okay, which is represented by the symbol E. Now tell me, for a parabola, what is the value of E? So if I divide SP with PM, what do I get as an output according to this condition? When I'm saying SP is equal to PM, then what will SP by PM be equal to?
1.
Yes, that's it. So for a parabola, the eccentricity is 1. So if you see, this word is sounding so tough to you, it is very simple. Okay, eccentric means something that is deviating from a circular shape. Something that is deviating from a circular shape is what is said to be eccentric. Some people call it as eccentric also. Okay, so here we pronounce it as eccentricity. So E is equal to 1. Similarly, for a circle, it will be 0. Because circle is not eccentric, it's a perfect shape, it's a round shape. Now, why I introduce this term is for ellipse, eccentricity is always less than 1. Okay, but you have to remember what do you mean by eccentricity, guys? Eccentricity. See, in the previous chapter, in the previous topic, I didn't discuss it because here it's the value is 1. So if you multiply 1 with anything, you're going to get the same output. That is why we didn't discuss about eccentricity. But in general, what do you mean? Eccentricity means, write down the definition. So it is the ratio of whom? Ratio of distance between whom? Focus and
Moving.
Divided by distance between moving point and fixed point. Sorry, fixed line. So what is the fixed line called as? That also we discussed last class. We have done problems also. It's called direct.
Lattice rectum.
No, lattice rectum is the chord. Directrix.
Yes, sir.
Yeah. Right. I hope it is clear.
Yes, sir. Clear, sir.
Okay. Now see. So whatever I'm going to do for horizontal ellipse, we need to exactly apply the same concept for vertical ellipse. Now see. Let's see the parts of the ellipse. Okay, so here it is given, see, eccentricity is given here. Okay, so I will show you what it is. Listen. So you're having all these points, right? X, Y. So what is the coordinate of this point, guys? It is a comma 0, and this point is minus a comma 0. This point is 0 comma b, and this point is 0 comma minus b. So what will be the 2 points on the axis S1 and S2? So now our interest of study is to find out what is S1 and S2. Okay. So observe. So if I call this point as A, then this point will be A dash. If I call this point as B, then this point will be B dash. So what does the definition of ellipse tell us? You take any point P on the ellipse, right? I'm repeating it. You take any point P on the ellipse, then the distance from S1 to P plus S2 to P is always a constant, right? So when this point P is moving, concentrate guys, when the point P is moving, let's say at one particular instant, B will also be a fixed point. Sorry, B will also be a moving point. Are you guys able to understand? So since B is also a point, look at the definition I'm going to give. Can I say, since B is also a point on the ellipse, Okay. Can I put it like this? S1b plus S2b should also be a constant. Guys, yes or no?
Yes, sir.
Right? Now, see, I'm taking, for the time being, I'm taking S1 as minus C comma 0, S2 as C comma 0. Clear? So what is S1b according to the definition? So I'll just go with the textbook one. Okay. So I'll make it even more simple. So instead of S1b, can I take it as S1a? Because that is a point on the x-axis. It is easy for us to cancel. Since A is a point on the ellipse, can I say S1a plus S2a should be a constant? So what is S1a, guys? So from the origin, what is the distance to point A? What is this distance? It is A.
A
Then what is this distance? I'm talking about distance.
minus C plus.
That's why I told it is distance. Don't take minus into consideration. Distance is always positive. So S1a is, can I write it as C plus A? Similarly, what is S2a, guys? This distance is C already. So S2a will be A minus C. Accepted. So what should S1a plus S2a be equal to? It should be C plus A plus A minus C. So C and C will get cancelled. Answer will be 2A. So we had been telling that the sum of the distances of whom, of the moving point to the fixed point is always a constant. No. What is the value of that constant?
2A.
2A is nothing but length of whom? It is the length of major axis. Is it clear, guys? So please make a note. So I'll go a little slow only because this topic is very tricky. You need to understand.
So I have a doubt, sir.
Yeah, please ask.
So, sir, this is for the points are on the x-axis, sir.
Mm-hmm.
So if it's in y-axis, it won't be 2A. It will be 2B, no, sir.
No, it will be 2A. That distance is fixed. I'll prove it. I didn't take the point on the y-axis because if you want, I'll prove it in the other way also. Can I say S1a dash plus S2a dash also to be a constant? Can I say S1a dash plus S2a dash should be a constant? Because when the point P is moving, there will be one. See, imagine this like you're moving on an elliptical path. Okay. Let's say you have a cycle, you're riding the cycle on this elliptical road. You're at point P at t is equal to 0. So you're moving in the anti-clockwise direction. So there will be one particular instance where you're at point A dash, right? So that point A dash, can I call it as a moving point? Because you're not stopping there, you're still moving. But that A dash is one of such instances. So according to the definition, S1 is a fixed point. So the distance from the fixed point to this moving point plus the distance from the next fixed point to the moving point should be a constant. So what is S1A dash, guys? I am saying it is A minus C. Plus what is S2A dash? I am saying it is A plus C. What will you get? You will still get it as 2A. Rohan, you're able to understand?
Oh.
Okay. So here one important point I wanted to conclude is, if you're talking about an ellipse which is horizontal, you will always get 2A. If suppose I do the same theory with respect to a vertical circle, then I will get 2B. Clear? So very important point to be kept in your mind. Good that you asked. Okay. So once we find out what is this, what is the value of C in terms of A and B, then we will try S1B and S2B also. Shall I proceed as of now? Shall I proceed, guys? Tell me yes or no.
Yes, sir.
So listen. Now, what is the relation between focus point A and B? So if I take the triangle OS1B or OS2B, so I will take the triangle like this. I'll rather call it, this is B. So what are the coordinates of B? 0, B. The coordinates of origin is 0, 0. If I take S2 here, the coordinates of S2 are C, 0. Right? Then the relation between C, A and B is given as C is equal to root of A square minus B square. Remember this, I will prove this. That the value of C is given as root of A square minus B square. Remember this. Okay. Now comes the next important point. Now I'm going to define eccentricity of an ellipse. So write down this definition. So eccentricity of an ellipse is given like this. It is a ratio of distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. So you have an ellipse like this. Okay. So the center is going to be origin. This point is S1. So what are they saying? The eccentricity of an ellipse, E, is the ratio of the distances from where? The center of the ellipse to one of the foci. So if this is S2, what do we take this coordinate as? What is this distance, guys? It is C to one of the vertices of the ellipse. See, generally when they say one of the vertices, it is the which vertex they are trying to talk about is one of the vertices of the semi-major axis. That is an important point to be added. So C divided by A. So E is equal to C.
Horizontal ellipse, sir.
That is for horizontal. That is the reason why they told one of the vertices.
Okay.
Okay. Am I clear till this point? Is there any confusion? Because new terms are coming. Okay. So I assume there is no doubt. So E is equal to C divided by A, which implies C will be equal to how much? C will be equal to AE. So this is going to break the first point. From above definition, coordinates of whom? Coordinates of foci are S1 is minus AE, 0 and S2 is AE, 0, because what did we take the coordinates of S1 and S2 as? Minus C, 0 and C, 0, right? But what is C? C is equal to AE. So minus AE, 0 and AE, 0. Okay. Clear, guys? Now see. Now I told you I'll prove it here, right? So concentrate. If I take S1 here, that is minus C comma 0. So what is S1B, guys? See, this distance is B, this distance is C. S1B will be root of B square plus C square from Pythagoras theorem. Similarly, S2B will also be root of B square plus A square, sorry, C square. So according to the definition of ellipse, S1B plus S2B is how much? B is a point on the ellipse. So according to the definition of ellipse, S1B plus S2B should be a constant. And what is the value of that constant? I told you it is always the same. It is 2 times what?
Times A.
It is 2 times A. But S1B plus S2B is root of B square plus C square plus root of B square plus C square. Can I write it as 2 root of B square plus C square is equal to 2A? So 2 and 2 will get cancelled. Squaring on both sides, what do you get? C square is equal to A square minus B square. Is that clear?
One
So-
minute, sir.
You're writing it down?
Yes, sir. Done, sir.
Now write down the next heading. A relation between A, B, and E. Okay. So look at this. Since C square is equal to, what did we get? C square is equal to A square minus B square, and C is equal to AE. These two are known to us. So this one we just now proved, and we told C is equal to AE from the definition of eccentricity. So using both, can I say A square E square is equal to A square minus B square, which implies B square is equal to A square into 1 minus E square. This is a very, very, very important relation. Or I can write E is equal to root of A square minus B square divided by A. So E is equal to root of A square minus B square divided by A. Clear?
Yes, sir.
Now we will start the derivations. General equation.
Sir, I have a
of-
doubt.
Tell me.
Sir, will they ask derivations in exams as well?
No, they don't. But you have to know what is the reason. That is the reason.
Okay, sir.
Maths they will not ask. Okay. So now I'm going to take a general point P x comma y. We know this point is minus A comma 0. This point is A comma 0. S1, S2. Since S1P plus S2P is equal to 2A. Convinced? So what is S1P, guys? Root of x plus AE the whole square plus y square plus root of S2P is x minus AE the whole square plus y square is equal to 2A. Right? So, whenever you have sum of two square roots, you need to take one of the square roots to the other side and square on both the sides. So, root of x plus AE the whole square plus y square is equal to 2A minus root of x minus AE the whole square plus y square. So, when I square on both the sides, what will you get? It will be x plus AE the whole square plus y square is equal to 4A square plus x minus AE the whole square plus y square minus 4A into root of x minus AE the whole square plus y square. So this is by squaring on both sides. So I would suggest you write it along with me. So tell me, what all terms will get cancelled? Y square and y square are gone. So from this we get x plus AE the whole square minus of x minus AE the whole square is equal to 4A square minus 4A into root of x minus AE x minus AE the whole square plus y square. So what is A plus B the whole square plus minus A minus B the whole square? That is 2AB is equal to 4A square minus 4A into root of x minus AE the whole square plus y square. A gets cancelled, 2 gets cancelled, which implies XE minus 2A XE minus 2A is equal to minus 2 into root of x minus A the whole square plus y square. Guys, is there any doubt till this step?
No doubt.
Okay. Now again we need to eliminate the square root. So for that what we will do is square on both the sides. So x square e square plus 4a square minus 4axe is equal to 4 into x square plus a square e square minus 2axe plus y square. Correct? Clear, guys?
Yes, sir.
So just a minute. 2a will get cancelled. Yes. So observe what I'm going to. 1 minute. I think I made a mistake. Just give me a minute. So x plus a the whole square plus y square plus x minus a the whole square plus y square is equal to a. Actually, I'm extremely sorry. So what we could have done is we could have squared here itself because I want that 4 to get cancelled. But wait. So when I square it, x plus a the whole square plus y square plus x plus a the whole square plus y square. So 2y square Just a minute.
So,
Yeah, tell me.
it should be 4x AE, I guess, sir.
Yeah, because I want that 4 to get cancelled. Where is it? Which step are you saying? You can
Last,
actually,
last one,
which
4x AE.
which
Last,
one? Which, are you telling here? This side.
no, sir, before that, sir, before.
This one, huh?
Two step before that, sir. 4x
This one.
AE. Ah, yes, sir.
Where did I miss it?
Left side, sir, 4x AE.
Ah, that is what I was looking. Yes, because that 4 has to get cancelled. Thank you. So 4 is gone, right? Now we'll get. So this is xe is equal to a minus root of x minus ae the whole square plus y square. See, I'm bringing the a to the other side. So xe minus a is equal to minus root of x minus ae the whole square plus y square. So squaring on both sides, x square e square plus a square minus 2a xe is equal to x square plus a square e square minus 2a xe plus y square. Now it is right. So what will get cancelled? X square a square, sorry, 2x ae and 2x ae will get cancelled. Which implies collect all the x square terms. X square into 1 minus e square plus y square is equal to a square into 1 minus e square. Okay. Now see what will happen is divide with a square into 1 minus e square on both the sides. So x square into 1 minus e square divided by a square into 1 minus e square plus y square divided by a square into 1 minus e square is equal to 1. Did you guys understand what I did? So what will get cancelled now? So 1 minus e square is gone. But we know an important relation. We know that b square is equal to a square into 1 minus e square. I've told you already. B square is equal to a square into 1 minus e square. Right? Since b square is equal to a square into 1 minus e square, what do we get the equation of ellipse as? X square by a square plus y square by b square is equal to. This is the relation, yes. Clear?
Yes.
Yes. So if you have an ellipse like this, if this point is a comma 0 and this point is a comma 0, then if I need to define a directrix, okay, a, if I call this point as S2, then according to the definition of eccentricity that I gave you, I told you the general definition of eccentricity, right? What was it? S2a divided by am should be E. right? So what is this distance? If I take this distance, if I take this point as k, comma 0, then this distance would be k, right? So what is S2A, guys? S2A is A into 1 minus E, accepted. S2A is nothing but A minus AE, that is A into 1 minus E, divided by, what is AM? AM is K minus A. So if this is equal to E, my work is to find out what is the value of K. So A minus AE is equal to KE minus AE. So AE and AE will get cancelled. So what is the value of K, guys? It is A divided by E. Hence, equation of directrix for an ellipse x is equal to k, that is equal to A divided by E. So remember what we did in parabola, what all they asked? They asked what are the equation of axis, what are the equation of directrix, what are the focus points, all those things were asked, right? Similar kind of questions will come here also. So when they ask you what are the directrix, you need to write it as A by E. What is the focus point? A into E. Clear?
Yes, sir.
The last term that is related is latus rectum. So what do you mean by latus rectum? So latus rectum is a chord which is perpendicular to the axis and passing through one of the foci. So if this is AE, 0, then what will be the coordinates of the endpoints of the latus rectum? That will be AE, let's say L, and the other end will be AE, minus L, where this distance is L and this distance is L. How to find L? Since AE, L is a point on whom? Is a point on ellipse. It satisfies the equation x square by a square plus y square by b square is equal to 1. So x is how much? AE. So a square e square by a square plus y is how much? L square. So L by b square is equal to 1. So a square and a square will get cancelled, which implies L square is equal to b square into 1 minus a square. What is b square into 1 minus a square, guys?
B square.
It is not a square. See, b square is a square into 1 minus e square. B square into 1 minus e square is not equal to a square. It is not the vice versa. So here what we are supposed to do is, in the place of 1 minus e square, you can write it as b square by a square. Can I write it like that? So b square into, can I write it as b square by a square? So what will be the value of L, guys? L will be plus or minus b square by a. So what is the length of latus rectum? It is 2 times b square divided by a. So let's write down all the points in a single place.
Could you go up a bit?
You want me to go up?
Yes, sir, please. That's a diagram.
Yeah. Right.
Done, sir.
So whatever points I'm giving is for a horizontal ellipse. So what are the equation for it? X square by a square plus y square by b square is equal to 1. So horizontal ellipse a is greater than b. Right. So what is the axis for it? axis is y is equal to 0 because it is x-axis. What are the foci? A comma 0 and minus A comma 0. What are the directrix? X
A by
equal
E.
to A by E and x equal to minus A by E. It will have two directrices. Reason being, I took the directrix on which side?
Positive.
So I took the directrix on the right hand side. Similarly, you will have another directrix on the left hand side also. Okay, so these are called directrices. Center 0 comma 0. Vertices, major axis A comma 0 and minus A comma 0. Minor axis 0 comma B and 0 comma minus B. Okay, last point. Latus rectum 2b square by A. Okay, there is a something else I forgot, that is eccentricity. So what is eccentricity? E is equal to root of A square minus B square divided by A, or you can also remember B square is equal to A square into 1 minus B square. Am I clear? So if at all you have a question in this exercise, they will ask you all these points. So if you are clear with this, I will start doing some problems. If I do 2-3 problems, you'll understand it. Okay. Listen. See, find the coordinates of the foci, the vertices, the length of the major axis, the minor axis, eccentricity, and latus rectum of the ellipse. So, what are the coordinates of foci? A given point, given equation is x square by 25 plus y square by 9 is equal to 1. Is it a horizontal or a vertical ellipse? Look at the numbers. So the general equation of a circle is x square by a square plus y square by b square is equal to 1. If a is greater than b, what is the name of the ellipse I told you?
Horizontal.
So this is a horizontal ellipse. So for a horizontal ellipse, you know what are all the points that you need to take. Right? So coordinates of foci, before we find the foci, we will find the vertices. So for vertices, coordinates of major axis minus a comma 0 and a comma 0. What is the value of a, guys? 5. So the coordinates of major axis will be minus 5 comma 0 and 5 comma 0. For minor axis, 0 comma b and 0 comma minus b. So what is the value of b, guys?
0 comma 3 and 0 comma minus 3.
That's it. So b is equal to 3, hence the vertices will be 0 comma 3 and 0 comma minus 3. Clear? Now we will find foci. So for us to find the focus point, we need the eccentricity of it. So what is the eccentricity? It is root of a square minus b square by a. So root of, what is a square, guys? It is 25 minus 9 divided by a is 5. So how much is it? Root 16 by 5. So 4 by 5 is the eccentricity. You always need to ensure that the eccentricity of ellipse is always less than 1. So 4 by 5 is a value which is less than 1. Okay. So eccentricity we have found. What are the foci? AE comma 0 and minus AE comma 0. What is the value of A? 5. So 5 into E is 4 by 5 comma 0 minus 5 into 4 by 5 comma 0. So this and this will get cancelled. 4 comma 0 and
Minus
minus
4.
1. So what is the length of the major axis? Length of the major axis is 2a. So 2 into a is 5, that will be 10. So length of minor axis, that will be 2b. So 2 into, what is the value of b? It is 3. It will be 6. So what all we have found? We have found the foci, vertices, length of major axis, length of minor axis. We have found the eccentricity also. So what are the lattice rectangles, guys?
B square.
This is 2b square by a. So 2 into b square is 9. A is 5. 18 by 5 units is the answer. So those are the questions will be in this exercise. Clear? Clear? So 18 by 5 units. So I'll tell you one more problem that you can try. So find the coordinates of foci, vertices, length of major axis, minor axis, and all those things. So here what will happen is, if you observe, you first need to bring it to the standard form. That is x square by a square plus y square by b square is 1. So if you do that, you will get x square by 4 plus y square by 9 is equal to 1. So this is a vertical ellipse. Okay. So for vertical ellipse, things will get reversed. So this I will tell you how to handle. So the problem that you can try from your side are first, third, fifth, and the ninth. So you can try out 1, 3, 5, and 9. Remaining problems will complete it tomorrow. So I want you all to work today and upload them. I've given only 4 problems. So 1, 3, 5, 9. Okay. So that's it for today. In tomorrow's class, we'll complete ellipse and L. So for hyperbola, I'm not going to show you the derivation. I'll just tell you all the important points and tell you how to handle the problems. With that, this chapter will be over. So this week, this chapter will be over. So let's see. Okay, be prepared. So make a note of it. Problem numbers are 1, 3, 5, 9. So just wait, don't leave.